Hello. Most often, we install GigE cameras on our lines. So now I will tell you about it. I will show you how to configure the cameras so that we can use them and use Cognex Designer. GigE is a standardized interface for transmitting video data and related data over Ethernet. This means that the camera has a standard RE45 Ethernet port and connects via standard network elements. For example, we could connect this type of camera directly using an Ethernet cable directly to our computer. Now here I have PC Novo, which is actually a compact full-fledged PC with passive CPU cooling, which is often desirable on the lines. But the camera also needs power, and if we connected the camera in this way directly to the computer's built-in network card, we would still have to connect it separately to 12 or 24 volts power supply using this power I/O connector, and thus we would need an extra cable for that. But many of such cameras also have the option of PoE, power over Ethernet power supply, which means that it can be powered directly via a communication Ethernet cable if, of course, the network card to which they are connected supports it. The built-in network cards do not possess the functionality. It is ideal when the camera has a dedicated communication channel with the computer, dedicated network port, so that the reception of images from this camera is not affected by other communication, which could delay the camera triggering, because it could also happen that the camera does not have time to capture what it should, or we could experience an unexpected slowdown in receiving an image. And since we almost always connect more cameras than one on a PC, we use a network card CFG8724 with 4 ports with PoE support. This card is designed for these applications. Surely most of you know how to connect such a card to a computer. But I also met people who didn't know and weren't sure about it. So that's why I will say a few words about it. So, this card uses the PCI Express X4 interface. When we look at the specification, the PCI Express X4 has dimensions like this. And in order to connect such a card to a computer, you need either X4, X8, or X16. All 3 of these will work. And since almost always for communication with the external environment, for example, with APLC, or to control lights, or other things, we also use the CIOC24 card, which has a PCI Express X1 interface. So, our computer should be equipped with at least this one slot, or greater than X1, that is, X1, X4, X8 or X16. When we look at our Nuvo, it has 2 X8 slots and 1 X16 slot. Since we use the X16 in Nuvo PC mostly for graphics card, we're not going to be using it now. When plug in the card, we should prepare a hole in this section. Sometimes there are metal plates, which are either screwed on, or they need to be broken out, or there is some mechanism for tipping, which should simplify work. And then we can mount the card by simply inserting it into the PCI Express slot. It should not require any greater force. If something is holding back there, you know you're doing something wrong. It should go pretty easily. At the same time, you need to be careful how this left part actually fits. Sometimes there are some guides that directly guide the card and help holding it. And when we insert it there, we should also screw in this upper part, because there are always some holes ready for screwing, or there is some mechanism that will hold it. Otherwise, that card could fall out later. And as you may have noticed, it is written here CFG8704E. This is an older card. Now there are newer CFG8724 cards. Although, this is a card that was supplied with the 3D system, so perhaps such label will still appear somewhere. This card also has a power connector, with which you can extend the performance of this card. You can connect it to this Molex connector on this computer. Normally, desktop computers have separate connectors. They may have more of them mainly from the power supply. Here it is directly on the motherboard. We commonly use cameras that do not exceed 4 watt power consumption. That is, we don't need to use this power connector. but we have found that it is more reliable when we do. Sometimes the video card GPU needs the connector too, because the PCI Express X4 can deliver 25 watt power without any problem, so for cameras of 5 watt each would be about 20 watt. It means that we have a safe reserve there. If we use the X16 slot, we have up to 75 watt. So if you need more power, you can either switch to the X16 or use this power port. We then connect the cameras separately using an Ethernet cables directly to this Ethernet card. For tests, any Ethernet cable may be good enough. But the cables we use on the line has screws on one side in the horizontal plane of connector, so we can screw it to camera like this. From experience, this is a much more reliable solution. If we know that the camera will be completely static on the line, then the basilar cable will be enough. Mark 10,170,259 is for 5 meters cable, or at the end with the ending 60, for 10 meters cable, or for a cable with number 61, that is 20 meters cable. Everything is on Confluence. Alternatively, from Cognex, the same cables are marked GigE ECBL Flex HXM, where the X is actually the length in meters, so 5, 10 or 20 meters. Those are the same Cat6 cables from the manufacturer Basilar. But from Cognex we can have them much faster if necessary. However, there is a possibility that the camera will be subjected to any, even small movement. It is automatically necessary to use cables from Elcom, marked TOG51 for T6TXM, where the X stands for length. 1, 2, 3, 5 or 10 meters. We have tried other flex cables, but they have not proved successful, and we often had more problems than good with them. When mounting on the line, it is of course advisable to mark the camera and cable, and I recommend marking the port as well. For example, with a permanent marker or something, which camera was connected to that port. Because when moving the computer or rewiring, it is easier to connect the cameras to the original ports than to reconfigure the system settings of the camera in the program. As I mentioned, we like to connect the cameras to a separate port so that they do not interfere with other communications. This is how it may look when everything is connected to computer with a display and with a communication with other systems. Often, we need to connect more cameras than 4. The standard license from Cognex allows the use of 8 cameras. However, it is possible to purchase an extension for an unlimited number of cameras. But what if we need to plug in so many cameras? If the computer allows it, we try to connect a sufficient number of CFG cards. If not, then we use post switch according to what load we estimate. For example, we can connect one switch to each port and connect 2 cameras to each switch, or depending on how you will be triggering and what speed you require. We often use 10-port post switches like Netgear MS510TXPP, which have 8 powered ports, and each camera has at least a gigabit interface. Here are also 2.5 and 5 gigabit interfaces, and each camera can be within 100 meters of the switch. If you use at least a Cat5e cable. We connect these switches to the PC using a 10 gigabit line, either metallic, which allows via Cat6 cable connection to up to 30 meters, or with the use of Cat6a you can pull up to 100 meters. And, for example, if you want a higher distance, which can be done even at 2 kilometers, you can use the optical interface 10GbASEXS FP+ of this switch. Of course, in combination with a suitable PCI Express card and APC that supports such an interface, and a module that you insert into this port. As I mentioned, the camera has a standard Ethernet port, and if you would need to connect, for example, to a laptop or computer, which does not support PO and you do not have a PO switch, or a suitable power I/O cable and power supply for it, you can also use some PO injector, to which you connect a cable that goes to the computer into one of the holes. Connect the cable that goes to the camera on the other side. And that cable is powered by this AC adapter. There is PO out. Well, I chatted a little. But now let's go to the configuration on the PC. For this, we will use the Cognex GigE Vision Configurator application, which we can access through Cognex Designer. Utilities, and here is the Cognex GigE Vision Configurator. Or directly through Start we write GigE and find that application. We will start it. In this application, we can then see all the available network cards, and here I can already see that I have some camera connected, but it is showing that the camera is on a different subnet than the network adapter. So, when I click on our network card, I see its IP address and subnet. And for those who are not very familiar with this, or they do not recognize this, I recommend to fill the knowledge gap, because this is always needed when setting up the camera. It's nothing complicated, but it's a bit beyond the scope of this video. So, this is the IP address with a subnet mask for the network card. And now we are going to adapt the IP address of the camera to this, so it will be in same subnet as the Ethernet card. So, this is a host IP address, the card address. I'll copy it and paste it here. And I see that the mask under the net is now set to the first 3 numbers, so I change the last. And also, the subnet mask has to correspond. So we have 355 numbers here. And there is also a checkbox for DHCP, which can be checked by default. But let's hit the update camera address right away and see what it does. If you have the DHCP checked, it may happen that the DHCP will be checked off when you update according to the manual setting. If not, then you can still tick off that DHCP just in case, in order not to automatically assign an IP, because the static setting is the most suitable for us. Next, GigE cameras also require jumbo packet setting to the maximum level. That is, so that they can handle big image data most efficiently. And that is here in the network card settings, we have MTU. That is, set maximum jumbo frame for the best performance. Now 9000 bytes is set, because we have used there a CFG card where it is set by default. But if we didn't have it there, if we were using some other card or other network element, we set it through these 3 dots. Here we also see it directly refers us that we have to go to Configure, Advanced tab. So, we go to Configure, Advanced, and here we have Jumbo Packet. And we have 3 options, Disabled, 4088 bytes or 9014 bytes. So, let's leave it set to 9014. It is always necessary to set a maximum for these cameras. At the same time, we see the firewall here. The firewall setting is now turned off, which is not usual. I'll show you how you can set up that firewall. So, through those 3 dots it throws you straight into the firewall settings. I'll go to Individual Settings, that is, Advanced Settings. Then here I have Windows Defender Firewall Properties. And for each individual network card separately, I have the option to turn the firewall off or on. So, I know that our network we use now is Ethernet 2. So, we can turn off Ethernet 2 completely. So Windows Defender Firewall will not check this connection. For all public, private, domain, and other settings as well, I'll give OK. Now I have a firewall disabled for this network card. I know there's only a camera, so I can go on. When we have configured camera like this, we can create a new project. I have now created a new project, but you can connect the camera configured in this way to any existing project. But it is important to at least restart the project if you had it open, or reopen it so that the camera appears here. Otherwise it will not appear to you here. So now I see that I have CIC_10 camera connected here. In this case, it is already automatically connected to the project, because we actually started that project with camera connected and ready to connect. So it automatically connected. If it would not be connected automatically, then you would only see here camera type and serial number. By this serial number, You can then identify the camera, which one it actually is. And you need to click on Add. For example, connect Cam 1. And you can work with it now. So, for example, I'm going to throw this camera in the task. I will give Run. And I see that I have received an image. It's black now because I don't have any lens there, so that's fine. And I see that I have my camera connected with this serial number. So, if you need to check what serial number each camera has, it can be done here, or it can also be found out directly here, through this. Or when you click on it, you can see serial number here. And what else do we need to set up? For proper communication with the camera, at least in most cases it is appropriate. Switch to this GigE tab. Change this latency level. If you use a CFG card, or a card that is dedicated to GigE, or directly on the computer, it is advisable to set 0 there. That is, you are telling to that connection that you have the best connection and the lowest response time. I recommend this setting mainly for connections to dedicated cards that you have on your computer. If you use a switch, you need to test it. If you use a switch, either put one there and test whether the one is working. If it doesn't work, input there a number 2 or 3, which is the maximum allowed number here. Mostly when we give switch we use the number 1. But it needs to be tested. It can be tested by either clicking this Run several times in a row. That is, several maybe dozens of times to see if you always have correctly received images. Whether there are not some higher numbers jumping there for getting an image. Whether it did not fall in error. Or launch this live display. And you can see on it whether it accidentally jams the video or throws some error. I do not recommend using this live display for high-resolution cameras because the VisionPro does not handle this live display so well, and sometimes it happens that the whole program freezes. It worked like this for us at 20 megapixels, so I think even higher it will work like this if it was not fixed in newer versions. Other solutions to problems with GigE cameras imaging and internal camera settings that can be done here will be shown in special parts later on.